Okay, so statistics is all about studying variation. It's how we talk in stats. This is another definition of statistics: the science and art of collecting, analyzing, and drawing conclusions from data. We're studying that variation in the data. So this is different than normal math class. Here we are defining words, vocabulary. These are two words you definitely want to know. An individual is an object described by a set of data. Individuals can be people, but they also can be animals or things, right? So it's what's being studied or described. Variable is a characteristic that can take different values for different individuals. So it's a characteristic of that individual. There are two types of variables that we're going to talk about. Categorical variables. These put peoples in groups or categories. And then there are quantitative. Think of quantity as a number. It can be measured by a count or a measurement there. So those are the two types. I think in stats, it's really good to look at examples. So here you can see in this chart, the individuals are actually the 50 randomly selected U.S. high school students. The variables are all the data they took from them, all the different categories or quantities they took from them, the state they were born in, the birth month, the age, the handedness, the height, the home occupants, allergies, and the preferred communication. Some of those are categorical variables. So some of those, all the words in this case, you have to be careful with that. Sometimes the words could be quantitative and sometimes the numbers could be categorical, but generally speaking, words, there's categorizing into, so you see, so in the case of categorical, birth month is really a categorical variable there. So that's where you have to be careful. So you're categorizing them into January, February, March, April. So those are categories there. So even though it's numbers, it ended up being categorical. So that's one of those you got to be really careful on. Because sometimes you kind of just go, oh, words, it's categorical, and quantitative are numbers, but that's usually true, but not always. Definitely allergies, yes or no questions, those are categorical. The preferred way of communicating, that categorical. Quantitative, in this case, the age in years, the number of home occupants, and the height are all quantitative. They can be measured or counted there. The distribution, this is another word of a variable, tells us how those variables take on and how often they take on different values there. So what's the frequency of that? So the frequency table shows the number of individuals having each value. There's also something called a relative frequency table. Think of relative frequency as percentage or proportion. But typically percentage, we typically will use a percentage with a relative frequency table. So now how often, well, what percent? So you could actually take this data and summarize it in two different kinds of tables. You could have a frequency table. The data, see, this is data for all 50 students, how they prefer to communicate. You can see right away text messaging is pretty popular, probably the most popular, it looks like to me. And so two different ways of displaying the data. You could say text messaging, 25 of the 50 students there on the left, that's the frequency of how often that answer occurs. 12 were in person, 6 were internet chats. Or you could break all those down into relative frequencies by either just writing the fraction or the decimal or the percentage there. So 12 divided by 50 is 24%. Those are relative frequencies. The proportions or percentages are relative frequencies, whereas the left-hand side is just how frequent are there, how many of them are there. Again, so frequency is just a count there. So that's the end of the first part of lesson A there. So I want to just a couple of practice problems, make sure you know what you're doing here. So I would definitely stop the video and just kind of, say, hey, what's happening here? So who are the individuals? 10 randomly selected large airports are actually the individuals. They're not people, they're airports. The variables are all those columns there, all of the columns. And then classify each variable as categorical or quantitative. So let's just go through each one. The first one, airport name, got to be categorical, right? Elevation, got to be quantitative. Those are basic. Municipality, categorical. Country, categorical. Radar frequency, I think quantitative. Runway, quantitative. And runway surface would be qualitative. Let's see if we got those all right. So categorical, municipality, country, runway surface. So they actually didn't call airport name the category there. That's just, I guess that's just the names of the individuals, which are the airports there. Okay. So make a frequency table and a relative frequency to summarize the distribution of fast food restaurants for the best chicken sandwich. So you would count them up, out of how many there are there, how many of those, what's the frequency of Chick-fil-A? 1, 2, 3, 4 Chick-fil-A's out of a total of, are there 5? 1, 2, 3, 4, 5. There are 5 out of the total of 27. And so frequency table, you're just doing counts there. So you're displaying those as counts. Whereas a relative frequency, you take that 5 for Chick-fil-A and divide it by the total of 27. 5 divided by 27. Just make sure that's true. So on your Inspire, 5 divided by 27, you put a decimal point, it'll give you decimal point 0.185. That's where that 0.185 comes from, right? So the relative frequencies. Do the data support a claim that the majority of Mr. Oster's students think that Popeyes has the best chicken sandwich? Well, Popeyes, 51.9% says, hey, Popeyes is the best. So yeah, I think the data does support that because more than 50% is a majority. Okay, lesson B. These are quick, easy lessons, hopefully for you, but I'm glad you're watching the screencast to find out the details. Displaying and describing categorical data. So now we're just talking about categorical here. So we can draw what's called a bar chart. Do you see at the bottom it has a title? Always put a title, always label the x-axis, what are those different categories there, and then the y-axis is the frequency. In this case, this would be just the percentage of students. So this is a relative frequency, so to speak, there. And so you get those by counting up how many of each one that you have. I think you had 25 out of 50 were text messages. That's 50%. So you draw up the bar to 50%. Notice the x-axis there. It's not really in any particular order. It's not necessarily from descending order to ascending order or something like that. You can just put them in the same order they started with. It would be fine. Shows each category is a bar. The heights of the bars show the category frequencies, or in this case, relative frequency, because they're percentages. And these are relative frequencies. And again, you can see right away, this is a different way of displaying data called a pie chart, which kind of lets you see in proportion to everything else, how big a slice, how big a piece of that. And this is a relative frequency because it's a pie chart, because they have percentages actually. The areas of the slices are the proportion, the category frequencies, and relative frequencies. To get those, you count them up and divide it to get that percentage. This is comparing things with a side-by-side bar chart. In this case, age groups on the bottom, teens or tweens, percent is the relative frequency there, and you can see the different comparison. Compares the distributions. In this case, of categorical variables in each of 2 or more groups. Group by age. And these are the percentages. This is comparing data, kind of interesting comparisons there with teens and tweens, the percent of daily screen time. So it does look like tweens tend to are not increasing like teens are. Teens are increasing their use of daily screen time on their devices, whereas tweens are staying somewhat uniform there after that first little bit. There's more folks that spend more time on screen time, grouped by daily screen time. Bar graphs are a bit dull to look at. It's tempting to replace the bars with pictures. A lot of newspapers or magazines might do this. They think it looks cooler, but mathematically it's not quite the same because the area is so vastly different. If you look at Windows, it's tiny, like 20 of those would fit in one Macintosh. I don't know, 25. Like they're so tiny compared to how big that screen is. The area is not representative of the disparity there because the Macintosh is like 350-ish, whereas the Windows is, I don't know, 0.75. So it should be like, I don't know, 5 or 6 or something, but not 20 of those little guys that fit in the big guy. Again, the area of the pictograph. Pictographs are terrible, we think, in general. And then watch the scales. You'll see an example maybe in a second about a scale that can be bad sometimes. Okay, so part B, we're done with the lesson. Let's just answer a few questions, get you ready for the quiz kind of thing. Olympics. So this is great. So we have the frequency table. So this is not a relative frequency table. It's just a frequency table. Can you make a relative frequency bar graph? So to do that, you would first have to start, converting all these to percentages. Let me just get this so we can see it. So you would type in 8 divided by 57, 32 divided by 57, and start getting all those percentages. So Asia is about 14%, Europe is about 56%, and so forth. So you can see the breakdown. To make a bar chart, you would have to take those percentages, chart them. We just got the 14 and the 58% there. You have to put a title at the bottom or on top. It's fine too as well. Olympic Games hosted by the region of the world. The categories there that we're studying, it's categorical data. So those are the individuals or the countries or the groups there, Asia, Europe, North America. And then proportions are the relative frequencies on the side there. It says to describe what you see, and it describes it as saying the modern Olympic Games have been hosted most often in Europe, 56% of the time, which is hosted more than twice as often as the next most common host, which is North America. Asia is hosted only 14%, and Oceania 5.3%, and South America 1.8%. Another bad graph called a pictograph. These are terrible. You can see the area of the first graph there dwarfs everything else. And so it's because of the area, it's just not. Pictographs is misleading because the total areas of the satellite make it look like the number of satellites owned by the United States is dozens times larger than the ones owned by China. That's not exactly true. Here's another bad graph. Same data as what we just had there, graphed differently. And it's kind of weird. I thought there was at least a small amount for China and United Kingdom, but I don't see anything there. So what they do different, I don't know if you notice it, but you need to notice this kind of stuff. So if you look at the y-axis, it starts at 10, and it should start at 0. There's no reason to start at 10 there. You're missing out two of the bars there. So it should have started at 0%. The scale was off. Because of that, it's not a very good graph because we can't even compare something that's invisible there. So here's your homework for the first week here, because most of this is just retreats. So you have 7 homework problems. Go ahead and write those down and do those and be ready for a quiz because I want to make sure you did this. We're just getting a ground started here. These are easy, fast lessons. But we need to take care of them and use those, because we'll use this not all year long, but those concepts are things we'll keep referring to somewhat often throughout the year. So I want you to do your homework. Great idea to read the book. I know that seems weird because it's a math textbook, but it's not really math, it's stats. And you'll catch some extra nuances. You'll see it maybe a little bit deeper or clearer when you do the reading. It's going to be very similar to the lesson. In fact, the lesson kind of helps you be familiar with the content of the reading, I think. But I think it'd be a great idea to do the reading just to get a full dose of the concepts that you're dealing with. And again, you might catch a couple nuances that we'll hit all the main points of the lesson, but you might miss a few things. And so the reading will fill in those gaps nicely. Also do the homework, right? So only 7 problems, very manageable amount of homework. They're going to do that. So you're ready for the quiz, confident going into the quiz, and you can do that. That's your lesson for today.